Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agricultural industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology. Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. We are glad to have you with us as we dive into the details of the NUtrack system for animal behavior monitoring, this with Dr. Ty Schmidt, Associate Professor of Animal Science at the University of Nebraska, as well as doctoral student Haley Beer.
With applications for traditional livestock animals as well as exotic and wildlife species, we think there's something for everyone in this episode. Let's get into our discussion of precision technology in animal agriculture with Dr. Schmidt and Haley.
So if we could start out, would you just kind of introduce yourselves and tell us what your role is at the university?
You want to start, Haley, or you want me to?
You can start.
So Ty Schmidt, I'm associate professor here at UNL. My appointment is 60% teaching and 40% research. And my research is really focused over the past 6-7 years looking at precision technology to identify immune compromised or injured animals.
My name is Haley Beer, and I am a second-year PhD student in the stress physiology lab, where I'm co-advised by Dr. Schmidt as well as Dr. Yates.
So Dr. Schmidt, would you get us started by kind of telling us what the NUtrack system is and how it works?
So the NUtrack system is a proprietary system we built here at University of Nebraska in terms of computer vision, programming, and software. And it's designed, I shouldn't say designed, its ultimate goal is that we'll be able to utilize this system to identify animals that are showing symptoms of illness or symptoms of injury or abnormal behavior that we can utilize to identify, and then the producer can verify or visually check those animals to improve the health and well-being of the animals. It's a really, I guess, from the hardware side, very simplistic. We just use high resolution security cameras that you can buy off the shelf at Best Buy or Target. Not that we buy ours there, we order ours straight from the manufacturer, but it's a relatively straightforward, simple hardware system. And then it's got some really complex machine learning algorithms that are built in to actually identify and track the individual animals.
Nice. So what kind of software is required?
So software, there's actually no software that's actually been developed for it. We do have the algorithms, machine learning aspects that we've created here at UNL. And to be honest, if I tried to tell you what they were, I would mess it up because the computer engineers are the genius behind the system. Eric Pasota, the guy that pretty much has built the program on the computer side. He's a phenomenal genius when it comes to computer vision, and he's the one that's built the whole programming aspects of it. So if we think of software, right now we don't have anything that can actually interface with a producer, something they can utilize, but at some point down the road, I'm hoping that we'll see somebody kind of pick up what we've created here at UNL and then make a software program that producers can actually utilize.
Cool. I actually know Dr. Pasota. He's really smart and he's a
genius. He is.
Yes, he's awesome.
They do all the heavy lifting for us.
Hey, I lifted some things, but not the computer side.
You were great at installing the cameras.
That's right. I can install a camera.
So
I just have a quick question for Haley. I know that you've spent some time working in that software and helping kind of facilitate the machine learning, helping get the system trained to recognize things. So I wondered if maybe you could share a little bit about how it actually recognizes body position and some of those details.
Yeah, so Dr. Pasota is actually kind of transitioning off of this project, and we have been working with a professor his name is Dr. Ben Riggin. And so he has kind of walked me through, it's called annotation, like the annotating process. So it's called annotation. And what that really entails is you're telling the software or how to write the program or the algorithm what these animals are, what they're doing. And in order to do that, you have these markers or bounding boxes of the software or program that starts this annotation process, where you're essentially looking at different frames of footage. And in each frame, you are telling the software essentially, hey, this is cat 1, that we will talk about later, I'm sure. But in this instance, we have 3 cheetahs at the Lincoln Children's Zoo that are housed together. So in this instance, you'll have Nane, Saba, and Sita. So you start off by telling the camera, okay, this is this cat, this cat, this cat. And then to orient it, the position of those cats, you'll have what are called markers. So you'll have a head marker, a tail marker, ears, really essentially anything that you think is necessary that can help detect the differences between those individuals.
That's really interesting. So I have a question for you, Haley. Where do you place the cameras and how are they placed?
So right now we have 9 installed at the Lincoln Children's Zoo. We have 2 outside in the exhibit area, and then the remaining cameras are on like the inside enclosures, and they are just cut up on the ceiling so that you can see the entire enclosure. And really all it takes is a ladder, some zip ties, and what Dr. Schmidt just mentioned, just a way to adhere that to the ceiling. So as long as you can see the area that the animals are in, that's essentially all you need.
Yeah, and the system's designed for an overhead approach. So we have to have the cameras up high enough that the field of view encases the whole enclosure. And with the cheetahs, we did have a challenge of making sure it was high enough away they couldn't jump up and hit it. So we've got it installed all the way at the top of their enclosure, so there's no chance that they can jump up and play around with it.
Sure. So we've talked some about how this is being applied in cheetahs, but I believe that this system was piloted in a pig or a swine facility. Is that correct?
That is correct. When we started the project, Eric and I, a colleague of mine brought us together because he knew I had a passion for finding a way to utilize technology to identify compromised animals. And he knew that Eric was working in the computer vision area, and he was having some challenges with tracking some human subjects. And so he kind of brought us 2 together, and it kind of worked out to be the perfect storm for us. Eric was having a challenge of just getting enough numbers of people to track, and I wanted animals. So we said, can we build a computer vision system for tracking animals? And he thought, yeah, I can. I'm a cattle person, which fits really well in the state of Nebraska. But we decided we'd work with pigs to start with because they are the most challenging one to track because they're all white. They all look the same. There's no color patterns. So we started with pigs, and we actually installed the first rendition of the system out at one of my advisees' swine units out now near Ulysses, Nebraska. So it's evolved over the past 6-7 years.
With the cheetahs, it's nice because they all have these different markings. And so over time, with enough frames that have been annotated, it essentially picks up these small changes or deviations that we don't see with our eyes. So as long as we have plenty of frames that are done manually, I also believe that we should have no problem adapting this to other species.
One of the things the system does is, the way I look at it from a non-computer vision person, is it creates a digital fingerprint. And I think once we give it enough replications of that fingerprint that it can verify it, then it's going to take over by itself and enhance that fingerprint. Like Haley said, we're annotating just body parts, but the computer is basically teaching itself to not only look at the body parts, but look at the patterns of the cheetah's hide. You know, this spot is this place, and it's so much more precise than the human eye. It can get down to pixel by pixel. So I think the sky's the limit with what we can track.
Absolutely. I wonder if we could talk a little bit about some of the outcomes of the data generated by this system. So this is picking up on any abnormalities from a baseline established behavioral pattern for individual animals. What can really be done with this data, or like what would be the next step once that abnormality is detected?
So we've actually started the next step now. Eric, again, with what he has built, we've moved into the next step. One of it's going to Haley's project and moving away from just livestock, but looking at exotic, you know, the cheetahs. As a meat scientist, I never thought I'd have a cheetah research project, which is pretty cool. But right now we've moved into that. We're looking at abnormal behaviors or damaging behaviors, like pigs. We don't know why, but sometimes pigs will actually damage or bite the tail of their pen mate to the point that it's actually very detrimental to the health. We've known this for 60, 70, 80 years, but we've never figured out the etiology or what causes pigs to do that. So we just got a large grant to actually see if we can use NUtrack to see if we can identify that etiology. The biggest thing, and trying to get one to your question, is we don't know what the normal behaviors are. We make some assumptions, and we've looked at video, short parts or frames of video to try to figure out normal. But one, each individual's, there's no such thing as a true normal. But the NUtrack system, I think this is the first time we've ever been able to track the activity of group house animals continuously. You know, and it's not something where once we've trained it, we don't have to watch video again. We constantly go back and check video and make sure that there's no glitch or something. But, you know, we ran it for 130 days and never really watched any of the video. The system did all of it. So we can tell you how many meters in a day each pig walked, how much time they spent at the feeder, or time at the water. You know, and this is completely new data that nobody, as far as we know, nobody has, because we've never been able to track them like this. It's also let us see some very unique things you never thought you'd see them do. We've seen a pig walk 5 kilometers in a 10 by 6 foot pen in just 5 days. We've seen just play behavior you'd never see, because when the human's in the room, they're kind of masking or hiding that behavior. So I think we're really setting a new bar with what we're able to identify with NUtrack that nobody else has been able to do.
I was just going to say, from a former zookeeper perspective, this is really incredible technology that I think could benefit not just zookeepers, but researchers in general. Zoo animals, you know, it's kind of a touchy subject for some, but as a zookeeper, I noticed several issues or places that I wish that we could improve. And I think that this technology allows us to do that. So in a day, zookeepers are pulled every which way. So they have a lot of time limitations. They have very an intermittent idea of what these animals are doing. So it's not comprehensive. And like Ty or Dr. Schmidt had mentioned, when you're in the room, you don't know if that animal is acting different than when you're not in the room. So it really kind of just bridges a lot of gaps and also provides a streamlined way to objectively look at behavior or assess behavior versus a subjective measure. Because I could go in and know these animals very well and say, it's odd that this flamingo is sitting in the back of the exhibit today. Whereas Dr. Schmidt goes in there, doesn't know these animals very well, and wouldn't think that that's something that's abnormal for that animal. So I think NUtrack is going to be huge if we can adapt it successfully in cheetahs and essentially other species of interest.
Very interesting, and congratulations on receiving the grant, Dr. Schmidt.
Thank you.
So, Dr. Schmidt or Haley, what differences are there in implementation and use in you guys' research compared to in livestock production?
So NUtrack was built, the whole goal was to get it into livestock. So we built it around making it fit into livestock. And so there's a lot of, I guess your question is, what are the challenges of getting it there? Or, how do we see it being implemented?
Yes.
What we built it for, started working with, is to see if we can identify those compromised animals ahead of time. And so ultimately, what I would like to see at some point is that a company will take or license what we've built here at UNL and create a platform where producers, swine producers or cattle producers can utilize NUtrack to monitor their livestock every single day and provide an early warning system or an enhancement to just visual observation, so that our producers can be more accurate and more rapid in identification of animals that have some concern, whether it's activity or they show symptoms of illness, or maybe it's even just an injury, they stepped wrong and they're limping. So that's kind of where I see it kind of playing into the livestock industry or production side of livestock.
We've mentioned it a little already, but Haley, if you wouldn't mind giving us an overview of your research project.
Yeah. So as Ty has, sorry, I keep calling him Ty.
It doesn't matter.
Please cut that out. As Dr. Schmidt has mentioned, our ultimate goal is to just comprehensively analyze cheetah behavior with this machine learning technology, or NUtrack. So we want to identify deviations from their normal behaviors and bridge gaps of things we don't know about them. So as I mentioned, we have installed 9 cameras so far. And this, again, will just offer a way of continuous monitoring 24/7, so that we're seeing how they're spending time in their enclosure. And this will also kind of capture their interaction, not with each other, but something that's a point of interest for me specifically is enrichment engagement. And enrichment is highly used in most zoos for almost every single species. And it's just a way to offer captive animals some sort of mental stimulation, given the constraints of their enclosure, comparatively to their wild counterparts. So for example, in snakes, they might get a different substrate like once a week, whereas higher cognitive animals such as primate might receive different enrichment items maybe 2-3 times a day. And again, this is just to try to get them stimulated mentally. So there are a lot of different types of enrichment, or they come in different forms. So this could be visual, tactile, auditory, olfactory, nutritional. So there are a lot of different options for these. And in cheetahs specifically, they are notoriously just not great with enrichment, meaning that they don't ever really seem too interested in it. And again, the overall goal is to get them interactive with something other than what we normally think of exhibit, where it's just these cement walls. We've done a lot in the zoo world to improve their welfare, but that's ultimately what enrichment is supposed to do. So part of my project is coupling the use of this NUtrack system with my interest in assessing different types of enrichment that the cheetahs at our zoo would interact with. So we have 4 different types of enrichment items for each category. So we have 4 categories, and it's rotated throughout. It's currently going on, but it's given, a type of enrichment is given in the morning and at night before the keepers go home. And then we'll utilize NUtrack to see how exactly they're interacting with it, the time of engagement. And again, we have to account for individual differences, but this will be a way to also inform other zoos that have cheetahs, like, hey, if you are interested in trying giving mirrors to your cheetahs, our cats really liked that. So that's another aspect of my project that I'm really excited to see the results of.
It sounds like you're very knowledgeable about your project, and you're very passionate about what you do. I'm just curious, Haley, what do the cheetahs do with the mirrors?
I really, I haven't seen it. I've gotten a few pictures from the keepers, but so far they have been very interested, just because it looks like another cat. So as far as I have been told, it was definitely a hit, or was novel for them enough that they kind of pace back and forth, just, like what your cat or your dog would do if they saw themselves in the mirror for the first time. It's not much different than that, but it is really encouraging when something that you give them is a hit and they interact with it, or you can provide them with that extra stimulation every single day.
What challenges have you faced with this project?
For me personally, it's a lack of time. It's really difficult to balance going to school and having other research projects going on in the Yates lab that have taken me away from being able to annotate. And the annotation process is not difficult. It's just very time consuming. You need a lot of frames to be able to train these algorithms. And we do have some promising results with, I think I submitted 800 or 10,000 frames before the semester started. And Dr. Riggin has said that it was doing pretty well at predicting the cats, but the only hindrance so far is not being able to identify the cats correctly. So again, that just takes more frames to annotate, to submit to Dr. Riggin to incorporate into this algorithm to better differentiate each cat from each other.
So I have a question for both of you guys. What has been your favorite thing about your involvement with this project?
Haley, I'll let you go first.
There are a lot of aspects about it that you don't really account for ahead of time. But I think it's been, I really like the interaction with the zookeepers. I feel like, having been one myself, and knowing the position that they're in, and knowing that someone is trying to gather information that can be of use for them and other zookeepers around the world, is really appreciative. In terms of they have busy schedules, but the fact that they're willing to implement this this design that I've had and correspond with me throughout it all has been just really appreciated. And I just truly can't thank them enough, because it's kind of a thankless job. And the fact that they're willing to collaborate with me is really meaningful.
For me, I'll say almost the exact same thing, whether it's the zookeepers or our producers, is just seeing their excitement with what we might have the potential to do with NUtrack. I think one of my favorite times was when we were first getting this system put up at the Lincoln Zoo, and kind of talking with the zookeepers and just kind of blowing their mind with what they see as the potential for this type of system, how it can improve the well-being of the zoo animals. And the same thing for our producers. I met with one last night in Columbus and talked to him about it. And it just kind of, you could see the light bulb come off in their head going, oh my gosh, this would make us so much better at ensuring the health and welfare of our animals. And so that's been the most exciting part, is seeing that we're doing research that hopefully is going to have a long lasting impact for both, the exotic animals, the zoo. But from my aspect, is if I can really enhance the producer's ability to ensure health and well-being, I mean, that's the best, that's the most exciting aspect of it.
For sure.
I'm curious, what kind of challenges do you anticipate in marketing this type of technology to a producer or a commercial market? So
we're not going to market it. I'm a researcher. Our whole team is researchers, so we're not looking to market the system. What what we want to see is, as we enhance this program, that some startup company or a current established company sees the value in it, and then they can license it from the university and incorporate it into their software. Because again, right now the only way to really access the data from NUtrack is if we have to dive deep into the programming of it to pull the data out. So it's not anywhere close to user friendly right now. And I don't see us moving past that point, because we want it for the research. We want to make the system as robust as possible. So what it's going to take for NUtrack to become something that's out in the producer's hands is going to be kind of up to a startup company or a current company to step in and say, hey, we see the value, we see the opportunity for not only enhancing our ability for health and well-being, but also, as a company, there's a profit to be made. So that's where it's gonna be. That's gonna be the biggest hang up, because I'm a researcher, I'm not a businessman, and really I have no goal of making money off it. I just want to see our producers have something that's viable for them.
So, Dr. Schmidt, do you have any advice for someone interested in incorporating this type of precision technology in a commercial or conservation setting?
I would say one of my biggest warnings as we move into this area of precision livestock is that all of these tools that we're developing are not designed to replace the human. We talk about how specific that camera can be and what it can see. It can see a lot of things, but it doesn't have our mental cognitive ability to truly take all the data and put it together. So I've heard it a lot of people in conversations, is that, man, this would get rid of 2 or 3 jobs. Maybe, but it's not to replace the human. It's to enhance the human's ability. So that's my biggest piece of advice, is as you're moving into this precision livestock, you're not doing it to replace a human being. You're just doing it to enhance the human's ability.
Exactly. And I feel like that's where most people get hung up at, is they think that, oh, technology can replace the human, but that's really not the case. It'll just help us.
What's one of the things, I talked to a colleague and she made a great point. If we take the human aspect out of raising livestock, or we take the human aspect out of being a zookeeper, those animals would become feral animals again. And that would be in the environment that we have, and that would be very detrimental to their health and well-being. So while we might think of interaction with the human being somewhat stressful, that interaction is extremely important to that animal, and to how it's mentally stimulated and how it responds to life in the system that we have it. So human interaction is not something we want to get away from.
Exactly. Thank you.
Yeah, Haley, would you like to share any of your thoughts or perspective on that?
Again, I think that it's just to add on to what Dr. Schmidt said, it's just a tool to be used in tandem to what we already know about our animals. As a zookeeper, those are your babies. You were there when it's -20 out in a blizzard, on the holidays, on the weekends. You were there all the time to care for those animals. So in order to better care for them, you will look at or take all the opportunities that will help you optimize their health and their well-being. And that's ultimately what zookeepers want to do, given that we all know that these animals didn't ask to be in captivity, but they were pushed out of their natural habitat. And this is the cards they were dealt. And we want to use them as a way to educate, but also provide them the best life possible. So again, I think most zookeepers, if you were to just give them a synopsis of what this project is, or what you could provide these animals, or the knowledge you could gain from it, they would all be on board. It's just a matter of, again, establishing how it works and the efficacy of it. So it is a long process, but it will be worth it in the end, I think.
All right, one final question here today. Is there anything we did not discuss that you would like to share at this point?
think the one thing, for me that's important is I'm not a computer engineer. I'm a meat scientist by training. And Haley is a vet, a zookeeper by interest and training. And so what's made this such a success is the fact that we've had phenomenal people to collaborate with. This by no means is something I did on my own. Actually, I probably provided a minor part compared to what Eric and Ben are doing on the engineering side. So it's truly a team effort, not an individual performance. And I think that's extremely important. You talk about advice for students, as they look into the research field. You can't do things by yourself. You've got to build a team. And I think NUtrack is a great example of how well a team can perform and what can come from teamwork.
Haley, do you have anything you'd like to add there?
I was going to say the same thing. I don't think it would be possible. I wouldn't be here if I didn't have the collaboration between Dr. Yates and Dr. Schmidt. Dr. Yates was kind of the mastermind that helped that fall into place. He knew that I had an interest in behavior or exotic species, and that I was out of a job because of COVID. And he knew that Schmidt had an interest in applying this or extending this technology to other species. So it kind of just fell into place. And if I've learned anything thus far, you just got to go with the flow. And it's worked out well for me so far.
Thank you for sharing that. We would like to include in this episode, where can we go to learn more about this work that's being done at the University of Nebraska?
One of the things is probably reach out to us right now. Be more than glad to talk to anybody that's interested or wants to know more about it. We're working on getting a website created where people can access a little more information about it. But as you know, at the university setting, nothing goes fast. So at some point we will have one, but they can always reach out to either Haley or myself, and we can definitely provide them more information.
Thank you very much to Dr. Schmidt and Haley for taking the time to join us for this episode of the FarmBits podcast. It's really exciting to see how technology is improving welfare and the health of both livestock and exotic species.
One of my favorite parts of this episode was the discussion of how technology is helping bridge the gap between livestock producers and conservationists or zookeepers. And I think we found out here today that those two groups really have a lot of common interests and goals when it comes to the well-being and health of their animals.
I am most looking forward to the future developments of this NUtrack camera system and its contribution to other species. I believe that the future is bright in the use of technology for the improvement of animal welfare and animal well-being.
We hope you enjoyed this episode, and we look forward to sharing another digital ag story with you next week.
Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the reviews section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.